Hey Beast, how we doing, my man? Let me turn this down. There we go. I think that's fine. I think that's okay. There we go. That's fine. It's 2 a.m. Beast, what are you doing up at 2 a.m., my dude? I mean, it's about 6 o'clock right here, 6 p.m. That's where I'm at, 6 p.m. So you're 8 hours ahead where I'm at. So you stay up till 5 a.m. What do you do? What are you doing till 5 a.m.? Jeesh. Are you just like trolling around online until 5 a.m. or do you have like a regular schedule? Like, I gotta know. Man, stay up till 5 o'clock in the morning. Oh, I'm a little too old for that anymore. Well, on most days anyway. Beast, what's the plan for the weekend, my dude? Oh, man. Let me go switch to the big cam. Hang on. Let's do this. Do this. How we doing? How we doing? How we doing? Hey. Hey. I also have insomnia. That's fair. You know, I had insomnia for quite a while myself. It's no bueno. You just can't go to sleep because you got too much energy. Or again, your just body just like, I'm just never tired. I'm never tired. I can't go to sleep. Blah 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 blah. Yeah, like poop. Everyone's jealous of you, man. Everyone is jealous of you. Holy smokes! I always wonder how am I so energetic. Tell them you're just naturally gifted. Just tell them you're naturally gifted. That's all they need to know. I tell them I'm built differently. There you go. That's right. You're built differently. That's just how it is. Like my mind is going like 24/7 most of the time. Thinking about something until I tire myself out and then I'll fall asleep without knowing what I was doing before. They stay up all night studying and so tired in the morning. Hey, when I stay up all night, nothing happens. You truly are a man of your moniker, a beast. It's just I don't know why it's like that, but it is. Julia, hello, hello. Do you feel like you study better because you're an insomniac? Sometimes I think I do. I do sometimes. How we doing today, Julia? I hope we're doing well. Not all the time. That's fair. That's fair. Yeah, sometimes it's okay. Sometimes it's like, okay, I probably need a little more sleep to digest the material. That's definitely fair to say. I'm doing just exactly as you mentioned here. Outstanding. Yeah, I'm doing outstanding. It has been a fantastic day so far. I hope it has been a fantastic day for you as well. I hope you've been doing very well. We're sitting and chilling, having a nice time. Hopefully you got some nice plans. 1 through 10. Yes. I'm not sure why you put that beast, but okay. I I can't answer that. I just wanted to. Fair enough. You may ask a question, of course. How am I so cool? The answer is that I'm not. Not even remotely close. I wish I was cool, but there is I would honestly say I am nowhere close to being as a cool dude, if you want to kind of call it that. I um I don't know. I how would I put it? Man, it's a kind of a complicated answer. Um man. The story I could tell would take a while to say. It would probably take me a little over a few hours to go over. In all honesty, it would be. Um, but let's just put it this way. Let's just kind of break it down into an actual serious, you know, 30-second blip. I suppose the best way to say this is that I grew up with a lot of different experiences. I grew up with a lot of different experiences, and with those different experiences, I realized there were things that certainly are outside of the norm that certainly could be done. Things could be done in a different way in order to achieve the same results. It's kind of like saying when you do a math problem, in certain math problems, there's more than one way to do something. And if I can achieve the same result doing that same thing, I said, why not try that over maybe what the supposed tried and true methods are? I'm more of a free spirit when it comes to that. I let people figure it out for themselves. If they fail, then they fail themselves. If they succeed, and they succeed for themselves. I'm there to help them. I don't want to help them fail, obviously, but I want them to succeed, and I want them to think things through in order to make themselves a success. I've been through, like in high school, I could tell you I was not a cool kid. I was the loser kid. Definitely the loser kid. I was bullied incessantly. That's just how it was. I was bullied every day for 4 years. Like, it wasn't good. I'm not gonna lie. I used to be super short. I was like 4 foot nothing in high school, and then I was like 5 foot nothing in high school, and then I only grew when I got to college. Um, but I just will say this: it's just like I don't want people to feel the way that I did back then. That's one thing. Like some people can take it two ways. You can either prevent that kind of feeling from happening, or you can keep going and encouraging it. I don't want to be the person that continues that type of cycle when you were in school. I want to be the type of person that at least at the end of the day will hopefully help you see some kind of growth, some kind of something that will some kind of something that will help you realize that yes, there's more to yourself than maybe what you walked in with. And as long as I did that, then I'm okay with that. I always mention that from the first day. If you walk in, if you walk out of this class, you walk out of this class or you walk out of anything better than what you walked in with, I'm going to be incredibly happy. And it doesn't have to move the needle much. I'm not saying you have to move the needle like, you know, a large amount. You move the needle a tenth of a percent or something. Then that's just fine too. You know, that's it. It's not like I'm asking a whole lot here. But some people when I meet them, in all honesty, uh, some people are not in the best of places, and having been through the experiences I've had, I've not been in the best of places. Places that probably many people would find pretty uncomfortable if I were to talk about it. But how do I make sure that those people never find themselves in those type of situations, or how do we how do we change the perspective around in order to see what the positives are in order to build off of that? I think that that's just as important. Math to me is a medium to in order to actually be able to do that. Um, I happen to be good at math, but I could literally say it could have been in any medium that I could have been teaching, and I probably would have been the same way. So math just happens to be my subject, but doesn't mean that the subject is always going to be the main focus of what I do in every class. So I know we just talked through. I know what I do is I just talk through a screen, and of course I talk with you, through a stream. But at the end of the day, I hope my words will reach people. I hope they do something good for people. I hope they can have fun time. I hope they can have a nice time, and I hope that there'll be better horizons down the line, and they can be a success down the line, and that we're all better for it at the end of the day. My goal for every person, besides just that, is for them to be better than me. I sincerely hope that to be the case, whether it be financially, or whether it be spiritually, or whatever you want it to be. I hope you're better. I hope you're at a better place. I hope you pass me, and I hope that you can take those feelings. You could take those feelings. You could take those experiences. You take that positivity, and you continue to keep passing it down over and over and over again. And Beast, let me tell you how that works. Let me tell you. That, my friend, is how you leave a real legacy. Is when it actually ripples through person through person through person through person. That one little change could cause, as they like to say, a large butterfly effect. And you never know what good things can happen because of it. That's it. It doesn't have to be profound. It doesn't have to be grandiose. It doesn't have to be this whole grandstanding thing. It could be something small that could lead to something so much bigger and so much better down the line. That's fine. And that's why I kind of keep my cool most of the time. Because that's what I aim for. And that's what I go for, And I've heard everything and under the sun and under the gamut. And, there's things that frustrate me. I'm only human, but most of the time I'm like, yeah. Let me listen to what you have to say. Let me see if I can understand your perspective and hopefully help you build from there if you have an issue. Okay, seems fair. I know that's a strange answer to a question that sounded a little simple, but that's the truth. I don't want to skimp out on the answer. I guess it was longer than 30 seconds. Sorry about that. Yeah, another question. I'm gonna have to get started here in just a moment. So, is my name actually Chibs? No. No. Chibs is just short for my screen name. So, Chibs is short for Chibs is Chibi, and then my actual screen name is Chibi Konbini. But it's hard to say Chibi Konbini, so I shortened it to Chibs because a lot of people actually said my name like that. One of my good friends actually said Chibs, and it stuck with a lot of people. My name? My name? You mean? Yeah, my real name, of course, is just Ali. That's pretty easy. I mean, there's nothing. Chibs is just my regular, internet name. But, no, my real name is Ali. Ah, so you're a boring one. I'm sorry, What do you want me to tell you, okay? I'm sorry, my name is like the John Smith of the Arab world. Sheesh, Beast. What do you want me to do, bro? I don't think I get a choice in that matter. I know it's a common name. You can walk down the street. You can walk down the street, man. I can walk down the street in the middle of Saudi Arabia. I'm pretty sure I'm gonna meet at least 15 of them. I mean, I ain't gonna lie. My parents are from Pakistan. So at least you're named after a legend. It goes a little bit. I mean, everybody knows Muhammad Ali, but my mom named me after somebody who was close. So like, if we're getting to just religious history, like in Islam, there's like the Prophet Muhammad, right? And so this Prophet Muhammad, and then his nephew was named Ali. So my mom named it after him. So that's a topic I can't really talk about on this channel. So if I I'm not gonna speak on religious things and whatnot because that's not what this channel is about. Because if I were to talk about myself in that regard, I can answer that on when I'm not doing a math class, but not during this stream. I just want you to understand that. I want to keep religion out of it. I just wanted to make an anecdotal story about what my mom named me after. That's fair. So, all right, I gotta get going here. Let's get started, ladies and gentlemen, with this thing because we gotta do it. Yeah. All right. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today we're going to be doing review here for Chapter 5, okay? So Chapter 5 review, we'll be doing some examples here, hopefully covering up every questions. Oh, don't get me wrong, Beast, it's not a privacy thing. It's just something that's just more appropriate for a different venue. That's all. I don't mind telling you, to be perfectly honest, and I'm perfectly comfortable with that. That's nothing wrong with that. It's just, again, just the whole different venue here. Alright? That's it. Pretty much. My whole voice changed? I guess that happens from time to time. I don't know why my voice changes. I think it's just made to adapt to other people. I have no clue why. I think I'm just used to doing that so much. In all honesty, it's really weird. Alright, anyway. Tone just shot up in the charts. Yeah, I know. Alright, so for today, everybody, let's go ahead and start with Chapter 5 here. Alright, so we're gonna go to the big board here, and let's see what we're talking about. Bye-bye. Time to get down to business, yes, yes. Okay, so today, in section 5.6, we're gonna be first talking about, again, the overall picture here of probabilities. So let's talk about probabilities here. All right, so we're gonna go over question number 21 here. So we're gonna transition from what we were talking about before. We're gonna transition to talking about the Titanic because, reasons. Yes, yes, Eli. Yes, you have a quick question. Go ahead. Absolutely, ask away. Please ask away. Ask what you like. If you guys have some questions for me before I get started, please ask. I'll be more than happy to answer. Why couldn't we use StatCrunch in the test, but we can in the homework? So basically, I don't. Basically, I take off all the on the test. I take off all the tools. So all the tools that are available, I take those off. And then the homework, I allow that. So like if you saw it on the practice test, I let all the tools be available. But then I take all the help me solve this and help do the example stuff. I take that off for the actual exam. Most of the time, you're not going to need StatCrunch. You'll use your graphing calculator to figure that stuff out. That's why I go through the calculator steps there. Because I have full expectation for you to go ahead and use your graphing calculator to figure stuff out. So, if that answers your question there. Yeah, so my full expectation is, even if you're not allowed to use StatCrunch, I don't want you to rely on it. You can rely on your graphing calculator to do the same exact thing. And we go through that process there carefully in order to find out what the answer to that question is going to be, okay? And like I said, anytime you feel confused, Eli, please come and ask me And I'll be more than happy to clear stuff up, or we can go over the process about button presses together or whatever. That's perfectly fine, okay? That's not a problem. As long as you're able to understand, you know, the purpose is for you to understand and hopefully get through that process without too much trouble. So, just ask me on Discord, just ask me on email, whatever you want, or we can just arrange a time. We can get that done, all right? That's no big deal. Ah, cool. All right, so let's answer some questions here about any other questions, by the way, before we go ahead. Any other questions? Please type no in the chat if you have no questions. Otherwise, if you do have a question, please type that out too. This page is page Sunla. Hang on. Okay. For some reason this is not active. Hello. Okay. Let's wait. Give me a second. Let me go look it up in the book here. For some reason it's not working. I'll come back to that in a second. This is page 288. 288. Yes, that's correct. 288, Sanma. Yes. All right. Okay. Hey. Hello. Give me a second here. Yep. Sorry. The book shut down on me. All right. Come on, book. Let's do this again. Let's do it again. Go to, actually, this will be, yeah, 288 right here. Alright. Let's try that again for some reason. Okay, so let's go to letter A. Alright. So what is the probability that we have a passenger who survived the disaster of the Titanic? Let's go over that here. What is the probability that someone survived the disaster of the Titanic? All right. What do we have here? How many people survived? Okay. The question is, how many people survived? Out of how many people did, how many people were on the ship? 711. Okay, very good. All right, so we have 711 out of 2,224 people on the ship. All right, very good. All right, so all you have to do is just take a look at the total of survivors over the total number of people on the ship. All right, and let's get a decimal equivalent for that. So just starting off with something simple and then kind of working our way up from there. All right, no big deal. 0.3197. All right, make sure that last decimal point is correct. Is that 97 or 98, Strolling? I think that's 97. I think you're right. Yes, okay, good. All right, good stuff. So far, so good. Okay, let's try another one here. Now, for this question here, I'm just going to let you know, I'm going to kind of skip around just a little bit, so that way we get a good look at many different types of questions here that we also saw here in Chapter 5, okay? So there's going to be a lot of different types of questions that we certainly will see here. So let's skip over to letter C. Let's get the probability that we have the person we select here is a female or a child. The probability that we have a female or a child here as a part of our random selection. So what do we do here if the probability for a female or a child, remember, the wording here is important. So female or a child. What do you think we should do here? Well, let's think of it this way. How many females were on board the Titanic? How many females were there? Okay, 425 plus 109. Okay, very good. All right, add total of both. Good. So there's 425 females plus the 109 children that were on board. And then we're going to divide that by 2224. All right, and so we're going to go ahead and get our final result here of, what do we get here? 0.2401. Okay. Good. All right, so far so good. Okay, now I'm going to ask a little bit of an offshoot question of this particular one. So let's talk about that here in this particular case. So what would be the probability here specifically of having a male or a survivor? So a male or a survivor here. What would we get here in this case? So the probability of selecting a male or a survivor. What would we get here in this instance? What would we do first? How much would that be? Well, let's take a look at it one step at a time, okay, everyone? So, how many males do we have here? Well, we have 1,690 males. Okay, good. And we have 711 survivors. Okay. And what else do we have to do there? We have 1,680 males, 711 survivors. And so Strolling, what's that 338 there? What does that reflect? I see we're subtracting there, but what does 338 mean? So you said we're going to subtract here, so we added the number of men plus the number of survivors. What does what does 338 mean? You guys got to tell me here. It's kind of important. Otherwise, male survivors already included in the total survivors. Okay. So, specifically here, Maritza, what we want to do is we do want to subtract by 338. Because remember, when we added the men, we had already here, these two guys were 1,690 men total. So we added the 338 here. And we added another 338 by counting the number of survivors. So 338 here represents, we counted the 338 two times instead of one time. So we're getting rid of the double counting by removing one 338. Essentially, this would reflect male and survivor. Okay, so remember that's what that reflects there, male and survivor here in this instance. And that is correct, so what Strolling had there is correct. Okay, and so we're going to go ahead and add those up together and divide by 2224. And does anybody have a decimal answer for me here? 0.9276. Okay, very good. All right, very, very good. Nice. All right, so far so good. Okay, any questions about that before we move on? Any questions? I hope that makes sense now. Again, that was one of those cases that we talked about earlier in Chapter 5, was when we had ORs. So we had to subtract by, and where they were not disjoint, they overlapped. So that's where that that subtraction comes from in that case. Okay, let's look at another one. Okay, so in this case here, let's look at the probability that we have a female and survived. So what would be the probability of randomly selecting a female and a survivor? Remember, the wording here is the word "and" here in this case. So again, please be careful about the wording here. What would we get here for this probability? All right, 316. 316. Okay, so there's 316 females and survivors. Okay. Divided by what? Out of 425? I don't think so. Not in this case. You can just keep it basic. So we just pick a female and a survivor. So there's 316 people, 316 women, 316 people who were female and a survivor. Out of how many people total? Out of how many people total? All right, 2,224. That's correct. Trigger Boy, thank you for the follow. Appreciate that. All right. So we have 316 divided by 2,224. All right, and again, this is our answer here. Let's go ahead and put it in decimal format. What's this as a decimal? It's 316 over 2224. What do we get there? Get our final answer. We'll move on to the next one here. .1421. All right. Okay, good stuff. All right. Let's move on here. All right. So we're going to do the next one here. Now, the next one here, I'm going to kind of guide you through just a little bit. All right. And we'll see exactly how we go ahead and approach this particular problem. I'm going to skip right to G here. All right. So it says here, if a child passenger is selected at random, what is the probability that the child survived? All right. So if a child passenger was selected at random, what is the probability that the child survived? Now, the important part about this problem is basically how we actually have to interpret this, okay? So, basically, this kind of goes down to the fact of when we talked about a few sections ago regarding conditional probabilities. This, too, is a conditional probability, all right? Now, the way it works like this is that we're making the assumption here in letter G that a child passenger was selected at random, because that's the condition that they gave us here. And we're trying to find the probability that that child survives. So again, what we're specifically looking at here is we're finding the probability that we survived given we randomly selected a child. Okay? So we have that. Now, let's look at this from, again, let's talk about given probabilities here, conditional probabilities. What you need to do first here is, if you're going to understand how to put together conditional probabilities, first, figure out your condition here. Notice our condition here is children, okay? Now, the real question is, how many children do we have total overall? If this is our given condition here, we need to look at the ballpark that we're looking at here. So we're going to figure out what's the total number of children here. All right? 109. That's correct. Okay. We're going to have here 109. All right? Now, out of those 109 kids, how many of them survived, according to our table? Out of those 109 kids, how many of them survived? 57. That's right, Maritza. All right, good. All right, very nice, Strolling. All right, that's right. Both of you are correct with 57. So our probability is going to be 57 over 109. And of course, we need a decimal equivalent with that. So does anybody have a decimal equivalent to that? 5229, okay? Good. All right, very good. Any questions about that so far? All right, we're going to look at a few more conditional probability problems, but just making sure at least we're clear about how that's going to work. All right. I want to let's look at a slightly different one here. Okay, so let's say we had a let's do another conditional probability here really quick. Let's say we had, okay, no questions from Horitz either. All right, that's perfect. All right, let's say we wanted to find the probability. Oh, why? All right. So I want to find the probability of, let's see, men given survive. Let's give the probability of men given survival. So we're just kind of switching things around. All right. So again, let's take it one step at a time. Can you guys tell me, what would we get here? What would be the probability of selecting a man given that they survived? Okay, 338 over 1690. It's a good guess. Remember though, Strolling, always look at your condition first. So Maritza, okay, says 338 over 711. All right? So we look at that, says, okay, well, how many people survived, right? We have 711 people survived the disaster of the Titanic. Well, how many of them were men? Well, 338 of them were men. All right. So 338 over 711 is correct. Nice. So what's that as a decimal here in this case? .4754. Good. All right. So you could talk. I like letter I for this reason. Is because do you think that the adage "women and children first" was adhered to on the Titanic? The answer is yes. A majority of women and children actually ended up surviving the disaster in comparison to the number of men. So, uh, in that case, yes. Actually, they did a good job helping as many women and children as they could in very dire circumstances. All right, let's go ahead and take a look here at the last one that you see listed here, which is letter J. And we'll go ahead and do the next problem here. So letter J says, suppose two females are randomly selected. What is the probability that both survive? Okay, so what we're going to have here is we have two female survivors, and we pick them back to back. We have first a female, again, we have a female serve. And again, we have another female serve. We treat this as no replacement, right? Yes, that is correct, Strolling. That is exactly correct. Now, the trick to this part is, though, and you found half the trick here, Strolling, so I agree. No replacement here because we're picking one female after another female, and they both happen to be in the same categorization of having survived the disaster. So, absolutely right. The other half of the trick, though, is actually first figuring out what the probability is of picking the first female survivor. But in this case here, if you take a look here, it says suppose two females are randomly selected. So we're given the condition here that it has to be a female. So we're given that we're see, okay, well, all right, we need the probability of having a survivor given that they're female. That's the other trick as part of the process. So, as Strolling has put down here, the probability of a survivor, given that it's female, we say, okay, well, for female, there's 425 females. Out of 425 females, how many of them survive? Well, 316 of them. And that's true. So we get 316 over 425 for the first one, and that's true. And then how about the second female there? The second female. Let's see. What do I see here? 315 over 424. That is correct. So because you understood that there's no replacement here. All right. So let's put 315 over 424. That is correct. So to explain how this works, is that since the first person we picked was a female survivor, that means there's one less surviving female in the pool, and there's one less female in the pool overall. So therefore, we have to subtract 1 from the surviving females. So that goes from 316 to 315. But since we also removed 1 female from the pool overall, that goes down from 425 down to 424. And then exactly, we go ahead and multiply those two guys together on our calculator. And does anybody have an answer for me here in this instance? What's the decimal equivalent here if we multiply these fractions together? That's our final answer here, guys. 0.5229. Okay. Good. 0.5224, 5229. Uh-oh. Like we got a couple answers here. So I'll need to check just to be on the safe side. One of those is correct. So 0.5224. Okay, so it is 0.5224. 4 here. All right, there we go. Okay, very nice. Okay. Any questions about letter J? I hope, again, that was talking about one of our concepts here. This specifically was without replacement. And again, we did use it here also in conjunction with a given probability. So, a nice little example to do. Let me put this 2 and 2 together. All right. Let's look at the next problem here then. All right, so the next example here will be number 26. So let's look at this here. All right. So it says here, in the game Text Twist, 6 letters are given and the player must form words of varying lengths using the letters provided. Suppose that the letters in a particular game are these, okay? Now, the letters themselves don't matter, but the letters are unique, okay? Each letter is different, so that's perfectly fine. Okay, so letter A. How many different arrangements are possible using all 6 letters? Now, each letter is unique, okay? So that's what we're given here. E, N, H, S, I, and C are all different letters. All right, and we have to make 6-letter arrangements. Now, notice it says arrangements, not 6-letter words. So whatever arrangements of letters that we have to make, it doesn't have to make any sense at all in terms of actually making a word. So we don't care about if it's a word or not. We just care that it's an arrangement of the letters. All right, so let's look at the first letter here. How many choices do I have for the first letter as part of my arrangement? How many choices do I have for the first letter? What do you guys think? How many choices do I have for the very first letter? All right, Maritza says 6. Strolling also says 6. Okay. That is, and Horitz and Eli all both say the same thing. All right, 6. All right, that's correct. Good. So we have 6 possible letters. So one of those 6 can certainly go into that very first spot right there. Perfecto. All right, go to the second letter. How many possible letters can go into that second spot there? How many choices do we have there now? 5. Okay. Hopefully we're going to see where this kind's going. It's kind of going in the direction you probably are thinking it's going towards. All right. How about the third letter? How many choices do we have now? 4. Okay. So we have 4 choices here. That's correct. All right. And I'm pretty sure you guys can pretty much guess here. Well, yeah, 6 choices for the first, 5 for the second, 4 for the third. I think you could probably guess here that we're going to have 3 and 2 and 1. Okay, so pretty simple after that. Again, pretty straightforward. Again, this will be 6 factorial if you were to just kind of boil it down. But you can also enter this in manually in the calculator since there are not too many numbers. But what do we get here? What's the 6 factorial? Or 6 times 5 times 4 times 3 times 2 times 1? What is that going to be? What's 6 times 5 times 4 times 3 times 2 times 1? All right, 720. Good. Nice. Very nice. All right. Any questions about that so far? Hopefully that's not bad. Pretty simple. All right. Let's look at letter B. How many different arrangements are possible using only 4 letters? So this time, we have 4 letters. 4-letter words or 4-letter arrangements here in this instance. So let's put in a 4-letter arrangement. All right. Well, how many choices do we have for the first letter here? It's a 4-letter arrangement. How many choices do we have for the first letter? We have 4 choices for the first letter. We have 6 choices for the first letter. Okay. So the answer is indeed 6. All right, so be careful. That's the trap you could fall underneath. Just because you reduce the amount of letters that are in that possible arrangement does not reduce the amount of choices that you have. We have 6 unique letters. That means we have still 6 possibilities we can put as our first letter in our arrangement. Okay, it's tantamount to saying, okay, if I have a 2-letter word and I can use the entire alphabet, well, I'm going to have 26 choices for my first letter in my word. That still holds true. So, doesn't mean I can boil it down to 2, get 26 choices still. All right, how about the second letter? How many choices do we have now? 5. And you can pretty much guess what happens after that. I'm pretty sure you guys have figured it out already. We get 4, and we get 3. And since there's only 4 spots, then, of course, things get pared down just a little bit. Alright, and what do we get here? 6 times 5 times 4 times 3? What's that gonna be? Hee 360 is correct. Okay. Alright, any questions about that? Hopefully that's pretty straightforward. It's not too bad. Alright. Alright, let's go ahead and take a look here at the next problem. Or the last example, really. I'm going to do one more example here. Alright, just one more example. Okay. Anywho, let's go ahead and take a look here. And let's do 31. Okay. 31. Let's do 31 here. If the 2015 Hyundai Genesis has 2 engine types, 2 vehicle styles, 3 options packages, 8 exterior color choices, and 2 interior color choices, how many different Genesises are possible? Okay. So can anybody tell me here, what do we have to do in this case for number 31? What should we figure out? How can we figure out how many different ways, how many different possible ways we can have these different types of the same car, I guess is the best way to put it. Many different ways to build a car. How many ways can we build that same car, according to what we see? What do we do? All right, that's correct. Multiply. We may do one more problem after this. This one's... All right. Okay. I agree. So if we multiply all these straight up, what do we get here? Two times 2 times 3 times 8 times 2. 192, that's correct. So the 192 possible ways to build this one type of car. Seems fair. Alright. Let's do one more here. I'll do the one right before it, because that one's also a nice quick problem. I'll do 30. Exercise routines. Todd is putting together an exercise routine and feels that the sequence of exercises can affect his overall performance. He has 12 exercises to select from, but only has enough time to do 9. How many different exercise routines could he put together? Alright. So he only has enough time to do 9, and he has 12 to select from. Can anyone tell me here how we could figure out how many different routines he could put together? How many different routines can we say that he could have here? Not 12 times 9. That doesn't make sense. Don't forget, this one has stuff, not 108. No, guys, you're thinking too, he has a pool of 12 exercises, and he has to pick 9 of them. Think about what we did in the last section, last class. Remember, we had permutations and combinations. What do we do there? Does order matter here in this case? Does order matter? Okay, I think you answered that. Good. The answer is no. Order does not matter here. So I agree with Horitz here. It is indeed 12, choose 9. We have 12 exercises, and again, we're gonna pick 9 of them. Fine. Okay, seems fair. So we do 12, choose 9. We could do that on the calculator here. So again, you go to, let me go quickly on the calculator, give you a friendly reminder from last time. Let me just bring up the calculator here for just a moment. Alright, so in this case here, we have 12. And we want to hit the math key. Go to PROB. Go down to number 3, which is NCR. And then hit the number 9 right there. And we can hit enter on that. And indeed, that is correct, Strolling and Maritza. The answer is 220 different ways. Okay, very good. Any questions? Any questions at all? So, differentiating between combinations and permutations. Combinations is when order doesn't matter. Okay? Permutations is where order does matter. Okay. So, so why do we not do for the letter combination? So you're talking about the previous question there, Horitz, right? Why would we use, say, permutations for like 26 if that's your question there? Is that correct, Horitz? Okay, so the reason why in that case is because in that instance, and let's go back here for that question. In that question, we're looking for different arrangements of letters. So if I were to say, let's look at this arrangement of letters of E, N, H, S, I, C, well, a different arrangement of that is if we went C, I, S, H, N, E, okay? This is a different arrangement, okay? Even, again, same letters, sure, but again, different arrangement altogether. So order does matter in that instance, because we cannot claim that ENHSIC is the same as CISHNE. Again, it's just like if you spell words, it's the same idea. One word is completely different than another word, even if they do use the same letters here. So that's why we used a permutation in that case. Hence why, as you see here, Horitz, I drew out the boxes appropriately to basically logic it out and say, hey, this is going to be the number of ways that we get to our final answer here at the end of the day. Hopefully that answers that question there. I hope so anyway. If you have an additional question, or you need me to clarify a bit more, just let me know. Yes. So for this one here, for letter A, you could use NPR for that. So, for example here, Horitz, you could have 6, we have 6 factorial here technically, so in effect we have 6 permute 6 is essentially what we have here. So you technically have 6 factorial over 0 factorial. 0 factorial, as we talked about here, is 1. You have 6 factorial divided by 1, which is equal to 6 factorial. In the second case here, we have 6 permute, and we're permuting 4 of those. So then this is what you get, 360 is what you get for that instead. So you can try that out, and actually you will see that it exactly works out the way we are using NPR here. Just, again, logicking our way to get to basically using NPR in that same fashion. You have this weekend to lock down this chapter? Good. That should give you plenty of time to get things right.
It's all about humanity.
No problem. Again, it all comes down to if order matters, like in letters, order will probably matter, okay? Because, again, different letter arrangements are unique. They're different. But, like, for example, number 30, it doesn't matter which order we do the exercises in. He just wants to do 9 random exercises in any order. So, okay. So, doing one type of exercise and swapping it with a different type of exercise, and, it's like, again, Bob, Mary, and Jane is the same as Mary, Jane, and Bob, like in a committee of people. Well, okay, who cares exactly how you write down the names? They're still the same people. Whereas the arrangement of letters, well, that's a completely different story. Okay, so I understand it's a little bit of a little bit tough there, but again, understand, at least answer the question first. Does order matter in that situation? Yes or no? And then you can use the appropriate operation with that. Combinations for not mattering, and permutations for it does matter. So a race would be a permutation. Okay. The lotto is a combination. Yeah, it's just like Maritza, I'm going to be honest with you, it depends purely on context. So you have to read through the problem carefully and then answer that question first. Okay? So it will take a little practice to getting used to, but yeah. That's kind of the mindset you want to be in when you do have to answer that question at that moment in time. And that's a fair question. I know that at first it's a little bit of a struggle, but you'll begin to see the pattern there behind that. Are there any other questions you guys have? Any other questions? In that question, yes, Strolling. Yes. In number 26, the answer is yes. When you have letters and you're talking about arrangements, then yes. In that context. Remember, I'm going to stress this very carefully, Strolling. That's in that context. So again, each problem is going to be different. Read through it carefully, and then you have to answer the question whether or not order matters. And then proceed to go ahead and do your calculation from there, okay? So that's why I'm not going to say this is always going to be cut and dry this way and this is always going to be cut and dry this way. Read the problem and then make the determination, okay? If they care about it, then it's probably going to be permutations. If they don't care, it's combination. Any other questions? Any other questions? I want to be able to clear up any misunderstandings or anything like that, so... No. Oh, of course. No, thank you. Thank you for asking. Hey, look, I don't know what you guys are thinking, so, you know, you ask, and I'll be more than happy to provide answers that will hopefully be able to clear things up as much as possible, so... Alright. Okay, ladies and gentlemen. If there are no more questions here, then I want to, let's go to the big face screen thing. I want to thank everybody for coming on out here to the stream once again. All of you, that is the end of Chapter 5. We did a review for that, and so for next time, we're going to be starting Chapter 6, okay? So Chapter 6 is what is next on the docket here for next time, okay, everybody? All right, keep working through Chapter 5 there. Make sure to keep working through that homework, okay? Just to kind of, as you guys have mentioned here today, just kind of digesting through the material, just trying to understand how, in this case, permutations or combinations or other probabilities may work. All right? Otherwise, again, you guys can contact me via Discord or email me. I will be here, and I'll be more than happy to talk with you if you need help, all right? But in the meantime, everybody, I hope everyone has an absolutely wonderful weekend. All right? I hope everybody has a nice time, getting us a little rest and a relaxation. Have a wonderful weekend, everybody. We will be back right here on Tuesday. Also, over the weekend, guys, I'm going to be working on uploading your grades from the test and the homeworks there. So I'll be working on putting that on D2L and whatnot. So you'll see that probably closer to the end of the weekend. I'll have that ready to go. All right, everybody. Thank you so much. I love all of you. All of you are absolutely fantastic today. All right. Again, take care. Have a great weekend. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Take care, everybody. We will see you later. Have a great weekend, Horitz. Have a good one, Sanla. Take care, Maritza. All right, Strolling. Have a wonderful weekend. All right, everyone, take care. All right. We will see y'all later. All right. See you later, everybody. Take care. Bye. Bye. Bye, everybody.